To Maheshwari chemistry classes. This is a organic chemistry important reactions part 2. Already 7 reactions over in part 1. Now Gatterman-Koch reaction. Okay, so please subscribe my channel Maheshwari chemistry classes. Please give me your support and like this video. Listen carefully. Gatterman-Koch reaction. Benzene when react with the carbon monoxide in acidic medium in presence of anhydrous AlCl3 aluminum trichloride to give benzaldehyde. Mainly Gatterman-Koch reaction product, what is that? Benzaldehyde. From which one? Benzene. So simply benzene 2 we have to prepare benzaldehyde. Okay, so benzene react with the carbon monoxide. Okay, in the presence of acidic medium, that is why here we have to keep H plus symbol, nothing but it is a HCl compound. Okay, anhydrous means waterless. Okay, so AlCl3 we have to use. Okay, then automatically benzene is converted like a benzaldehyde. On phenyl group, nothing but on benzene group, one of the hydrogen is replaced with the aldehyde, that is why it is known as benzaldehyde. This is about a Gatterman-Koch reaction. Once again, Gatterman-Koch reaction product benzaldehyde. From which one? Benzene. Benzene to benzaldehyde formation, Gatterman-Koch reaction. Next we have same name, that is Gatterman reaction, not Koch. Here no Koch, only Gatterman. Gatterman reaction, here we are using benzene diazonium chloride or benzene diazonium halide. X nothing but halogens, that may be chlorine and bromine. Okay, here benzene diazonium halide, when it is treated with the HCl in presence of copper. Okay, here diazonium halide is replaced with the chlorine and nitrogen and copper halide eliminated. This is the chlorobenzene is the main product. In presence of HCl it will give chlorobenzene. In presence of HBr it will give bromobenzene. Remember, here also copper, here also copper. Simply benzene diazonium chloride will form chlorobenzene in presence of copper and HCl. Okay, benzene diazonium halide, it will give bromobenzene in presence of copper and HBr. Okay, chlorobenzene and it is bromobenzene. That's it. Next one is a Sand-Meyer reaction. It is also very important reaction for board. Listen properly. Sand-Meyer reaction. What is this? The nucleophiles. Nucleophile nothing but negative charge, right? Negative charge containing ions, especially chloride, bromide, cyanide, can easily be introduced in the benzene ring. Okay, these ions, which ions? Chlorine, bromine, cyanide ions, easily substituted or easily introduced where? On benzene ring in presence of copper 1 ion. This reaction is known as Sand-Meyer reaction. Remember, here also same as it is benzene diazonium chloride we are using. Okay, it will react with the HCl in presence of copper chloride. Okay, here Cu2Cl2 we have in this presence. What happened? Chlorobenzene is formed. Don't forget, Sand-Meyer reaction product, Gatterman reaction product same, reagent also same, but the middle reagent, this middle one is a different. What is that chemical? Here copper we are using. Copper using is the Gatterman. Here Cu2Cl2. Copper chloride using is the Sand-Meyer reaction. Remember once again, Cu2Cl2 we are using for Sand-Meyer. Simple copper is using for the Gatterman reaction. Here also benzene diazonium convert like chlorobenzene or sometimes bromobenzene. HBr presents bromobenzene, HCl presents chlorobenzene. Here also benzene diazonium chloride converts like a chlorobenzene in presence of Cu2Cl2. Okay, if we use Cu2Cl2, that is a Sand-Meyer. If we use simple copper, that is a Gatterman reaction. Remember carefully. Okay, Next important reaction is a HVZ reaction, Hell-Vollard-Zelensky reaction. H nothing but Hell, V nothing but Vollard, Z nothing but a Zelensky. Okay, so here alpha hydrogen containing carboxylic acid involves in halogenation, especially in presence of red phosphorus. Which phosphorus? Red phosphorus, and it will give alpha halocarboxylic acids. Okay, which position? Alpha position contains which atom? Halo atom. Okay, halogen atom containing carboxylic acids are formed. That is known as HVZ reaction. Here look at this. Carboxylic acid purpose compulsory. Which is compulsory? Alpha carbon compulsory, alpha hydrogens compulsory. Okay, this is a main functional group. C double bond OH is there. Okay, this first adjacent position, beside position is known as alpha carbon, and alpha carbon containing hydrogens are known as alpha hydrogens. For this alpha hydrogens are mandatory for HVZ reaction. These hydrogens are convert, like especially these hydrogens, one of the hydrogen is substituted with the halogen atom, especially which halogens? Chlorine or bromine. Okay, in the place of X we have to take either it may be chlorine or bromine. Okay, here what happening? This is the main functional group, right? This is alpha position, right? Here one of the hydrogen is substituted with the halogen atom. Which halogen? Either it may be chlorine and bromine. If chlorine involved, that is alpha chlorocarboxylic acid. Okay, if the bromine involved, alpha bromo, what is that? Alpha bromo carboxylic acid. That's it. Okay, so with which one? This CH2 COOH, alpha carb. That's it. Okay, this reaction occur in presence of halogen molecule and red phosphorus. Okay, and we have to do hydrolysis. For that purpose we have to take water. Simple. Alpha hydrogens containing carboxylic acids treated with the halogen in presence of red phosphorus and involves in hydrolysis, it will form alpha halocarboxylic acids. This is known as HVZ reaction. Okay, next important reaction is coal-base reaction. Okay, once you check, sodium salt of phenol when heated with the carbon monoxide at 125 degrees Celsius under 4 to 6 atmosphere pressure to form salicylic acid. This is known as coal-base reaction. Look at this. Sodium phenoxide, it is treated with the carbon dioxide. CO2 means carbon dioxide, and we have to heat this compound. Okay, these compounds heating in presence of 125 degrees Celsius and pressure required, that pressure is a 6 atmosphere. Okay, so here it will form a same sodium phenoxide is a, what is that? Here phenol group OH group is formed. First adjacent is a substitute with the COOH group. It is known as salicylic acid. Sodium phenoxide is converted like a salicylic acid. Okay, this is known as coal-base reaction. Okay, time is very less, that is why I am explaining very fast. So listen carefully. Next, Williamson's ether synthesis. Simply Williamson scientist name, ether synthesis means ether preparation. That's it. Ether formula ROR, right? So this is known as ether. So we have to prepare the ether. Now listen carefully. The reaction of an alkyl halide with sodium alkoxide to form ether, it is known as Williamson synthesis or Williamson ether synthesis. Look at this. Here sodium ethoxide C2H5ONA. Okay, here ethyl iodide. For our convenience purpose I wrote. Why I wrote, once you check here. From here Na plus, from here I minus, both are eliminated as the sodium iodide. Here this ethoxide and this ethyl both will make a bond. So 2 times ethyl and middle oxygen is there. That is why it is known as general name diethyl ether. So it is also called as IUPAC name. What is the name of that one? Ethoxy. One is the main, another one is a substituent. That is why name of the diethyl ether is a ethoxy ethane. Okay, it is general name. Diethyl ether is a general name, ethoxy ethane is the IUPAC name. Simple. Again listen carefully. What here? Alkyl halides. Rx nothing but alkyl halide, right? So it is reacted with the sodium alkoxide. Sodium alkoxide, RONA. Okay, both are reacting, okay, with each other and forming, what is that? From here sodium, from here halide are eliminating, ROR is forming. This ROR nothing but ether. Okay, this is the Williamson ether synthesis. Williamson ether synthesis, ether's formation reaction. Next one, Hoffman bromamide reaction. Simple. Listen carefully. Amines are reacting with bromine in presence of potassium hydroxide forms amines. Here, sorry, it is amides. Okay, amide on treating with the bromine in presence of potassium hydroxide forms amines. It is called Hoffman bromamide reaction. Amide nothing but RC double bond O NH2. Okay, C double bond O NH2 group completely it is called as amide. Okay, it is treated with the bromine in presence of base. What is the base? Potassium hydroxide. Here look at this. This carbonyl group is eliminated. Here R and NH2 both will make a bond, that is RNH2 nothing but primary amine is formed. From amides to primary amine preparation. Okay, from amides to primary amine preparation. This amide is reacting with the bromine in presence of base. Which base? Potassium hydroxide. From amides to primary amine preparation is known as Hoffman bromamide reaction. It is also called as Hoffman bromamide degradation reaction also. Why? Because here carbonyl group is eliminating. Okay, this is about a Hoffman bromamide reaction. For this, actually this is the reaction mechanism. Amide RC double bond O NH2, it is treated with the bromine, and here especially NH2 group is involved. Okay, one of the hydrogen. Okay, so simply for your understanding purpose I am writing. From here H, here from this bromine Br, you may imagine these are eliminating. Here NHBr is formed. Here potassium hydroxide presents, same as is here. Water purpose, this H it is eliminated with this OH. Here same as it is minus charge is formed. Why? Because it donates the electron towards nitrogen side. Extra electron containing N minus is formed, and again here Br minus eliminated. Here extra charge is eliminated. So now nitrogen will contain 2 lone pairs and one of the bond. Nitrogen group is 5th group, right? That is why 2 lone pairs nothing but 4 electrons, one of the electron. So it is known as acyl nitrile. This acyl nitrile is rearranged as isocyanate. It is important MSET bit. In Hoffman bromamide reaction, acyl nitrine is converted like a isocyanate. Okay, so this electron shifting and this electron will make a double bond like this C double bond O. Okay, sorry, this C double bond always there, and C double bond N is formed, and again it is attached with the R. Okay, in presence of water it will give directly amine. Okay, simply from amides to amine formation. Which amine? Primary amine. Why? Because this nitrogen contains 2 hydrogens. This is about Hoffman bromamide reaction. Next, Wolff-Kishner reduction. It is also very important reaction. Listen properly. Okay, so Wolff-Kishner reduction nothing but hydrogens adding or else oxygens elimination, right? Simply you have to remember, from this carbonyl group, especially from this carbonyl group, oxygen will eliminated. In the place of oxygen, two hydrogens are formed, nothing but this is the which reaction? Reduction reaction. Okay, so simple, when a ketone or else an aldehyde, it is treated with the hydrogen nothing but NH2 in the presence of base symbol OH minus. Okay, that carbonyl group is converted into methylene group, nothing but this C double bond O group is converted like a CH2 group. Okay, so this is known as Wolff-Kishner reduction. Wolff-Kishner reduction purpose main reagents are hydrogen and base, nothing but OH minus, and heat. So what is the reaction? Wolff-Kishner reduction. Okay, that's it. Here simply this is called acetophenone actually. So this acetophenone is converting like ethyl benzene. That's it. Simple. This C double bond eliminated as a CH2. Okay, so this is the reaction mechanism. If it is required, write down. Why? Because 4 named reaction combination they will give as a 1 LAQ. So that is why. So it is not mandatory, but remember once, check. These are the mechanism steps. If you want to prepare for this MCET or JEE mains, listen properly. Acetophenone containing this oxygen and hydrogen containing H2, both are eliminated as a H2O, and this double bond is made with the N. Okay, and this again in presence of base H plus is eliminated. Here this electron and this electron shifted, N double bond N is formed. Here extra electron will come, that is minus charge. Here again in presence of water we have to do this reaction. Here we have to add the reaction water. Here water is eliminating. Here water purpose, oxygen is a 6th group, right? Oxygen contain 2 lone pairs. Here extra charge containing oxygen, okay, it will take one more extra ion, one more extra electron, H plus is eliminating, that H plus is added here. This next, this is the stable compound. Again from here hydrogen is eliminated as a H place. Okay, and this total is eliminated as a N2. Next here extra active methylene purpose, CH2 forming purpose, here CH minus is substituted. This CH minus conversion, after again in presence of water it is forming ethyl benzene. Simple beta, you have to leave this mechanism, just you have to learn this for simple IP exam purpose. Acetophenone is converting like ethyl benzene. Here carbonyl group is converting like CH2 group. That's it. Okay, in presence of which reagent? Hydrogen formula NH2 bond NH2, and OH minus nothing but base, delta nothing but heat symbol. Okay, this is about Wolff-Kishner reduction. Next one is the Clemmensen reduction. The reduction of carbonyl group of aldehydes or ketones to active methylene group or active methylene groups, okay, with amalgamated zinc and concentrated hydrochloric acid. It is known as Clemmensen reduction. Simple, remember this trick. Carbonyl is converting like a CH2 group. Okay, in Wolff-Kishner also same. Carbonyl is converting like a CH2 group. That Wolff-Kishner purpose we are using hydrogen base heat. Here Clemmensen purpose we are using a zinc amalgam. Amalgam nothing but mercury present with zinc. Acidic medium purpose HCl we have to take. It is a reflux reaction. Okay, so here one of the example is acetophenone, general name 1-phenyl ethanone. Okay, so 1-phenyl ethanone, it is a main product you have to take. Okay, first position contain what is that? Phenyl group. That is why 1-phenyl ethanone, IUPAC name, acetophenone IUPAC name is a 1-phenyl ethanone. This 1-phenyl ethanone is converting like ethyl benzene. Simple, this carbonyl group here it is converting like a CH2 group. Okay, nothing but here oxygen is eliminating. In the place of one oxygen, 2 hydrogens we are taking. Nothing but it is a reduction reaction, right? So this is about a Clemmensen reduction. Okay, Clemmensen reduction occurs in presence of zinc amalgam ZnHg HCl, reflux reaction. Okay, so that's it. Next, Urge reaction. Urge reaction, simple, alkyl halides, okay, converts like alkanes in presence of sodium dry ether. We have to heat, that's it. Okay, alkyl halide is treated with the sodium metal. In presence of the dry ether, it will give alkane. Okay, what is the reagent? Alkyl halide. What is the main product? Alkane. That's it. Okay, for your understanding purpose, I want to write this simple reaction. Alkyl iodide 2 moles we have to take, or alkyl halide we have to take 2 moles. Okay, in presence of sodium. And what is that? Dry ether we have to take. Okay, waterless ether, nothing but dry ether. We have to heat from this iodine 2 atoms, sodium 2 atoms, both are eliminated as a 2 moles of sodium iodide. And simple, these two alkyl groups are joined with each other and will give a big alkane. That's it. Next, Urge fitting reaction. In Urge reaction, alkyl halides are converting like alkanes. Okay, alkyl halides are converting like a alkane. Okay, in the presence of a dry ether and sodium and heat. Here Urge fitting reaction purpose, look at this, a mixture of alkyl halide and aryl halide, it is treated with the sodium and dry ether, it will give alkyl arene. Here only alkyls if we take, only alkyl halides if we take, it will give simple alkane. But in these 2 moles of alkyl halide, one is aryl halide, another one is alkyl halide. Okay, alkyl halide formula is Rx, aryl halide formula is ARX. Okay, these are treating with the sodium. How many moles? 2 moles. So it is eliminating like which one? Sodium halide. NaX, it is a byproduct, and AR and R both are making a bond, nothing but it is a alkyl arene. Alkyl arene forming is the Urge fitting reaction. Simple alkanes forming is the Urge reaction. Okay, that's it. Here also dry ether presence, heat presence. Here also sodium metal presence. Okay, so simple, chlorobenzene, it is treated with the what is that? Ethyl chloride. Okay, in presence of sodium and dry ether. Here sodium chloride is eliminated, ethyl benzene is formed. That's it. Next, 2 more reactions we have. The reactions I will explain in next part. Already it is 2 o'clock. So sorry. If you like this video, please subscribe my channel, Maheshwari Chemistry Classes, and please share with your friends. Please give me your support. Thank you very much. Thank you for your patience. All the best. Learn properly, get good marks.